All right, I'm going to just do a quick summary of the investigations today. I'm not going to go through everything because the first time I did this, the sound was messed up. I don't really have enough extra time, but I'm going to summarize, and you can come in and ask questions. So one thing you have to remember is the definitions of an inscribed and central angle. So inscribed angles are this green angle would be an angle whose vertex is on the circle and endpoints are on the circle. And a central angle would be this yellow angle, vertex is on the center, sides are radii. Those are the two angles we're going to work with today. We're not going to work with the angles over here. These aren't central angles, even though you have angles inside the circle, like angles 1, 2, 3, and 4. They're neither central nor inscribed because of the location of their vertices. So I just crossed this out. We'll deal with these angles on a different day. This is the first investigation we did in class today. This is the chord central angle conjecture. And what we found out in class, if two chords in a circle are congruent, they determine two central angles that are congruent. So basically, what you know is that if you have two chords in a circle and they're congruent, they're marked by these markers. We also know that we have radii that are all congruent to each other. So by side, 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 the two triangles are congruent. Therefore, angle 1 is congruent to angle 2 by corresponding parts. So you'll use that property. The third property tells us that congruent chords form congruent intercepted arcs. So you have to know what an intercepted arc is. So I was drawing a little picture over here of kind of a Pac-Man. And this angle here in black intercepts the arc right here. So these arcs are the same, these arcs here, had those on the circle originally. That is arc AB, and the blue one is the same as arc BC. So if we look at this conjecture, it says if two chords in a circle are congruent, so we have this chord congruent to this chord, then the arcs they intercept are congruent. So you can see I have the tracing of these arcs. And just visually, if I line these up, they're also congruent. So that was another little conjecture we came up with today by doing some measuring. So one other thing that came up that's important is the measure of a central angle, measure of AOB, that would be angle 2. That intercepts arc AB right here. It intercepts arc AB because it cuts it off. So the way we define the arc measure is by the angle. So if this were, say, an 85-degree angle, this arc would also be 85 degrees. So a central angle equals the measure of its intercepted arc. The next conjecture says perpendicular to a chord conjecture, the perpendicular from the center circle to a chord. So if I drew a perpendicular from the center of the circle to a chord, just kind of sketch that in there, then what must be true? And it tells you to do some, measuring. So if this was perpendicular, if you you measured in class, you would have found out that the chords bisected. And then I said that you could do this with a triangle proof. So since this is a perpendicular, and these are radii are congruent, we have an isosceles triangle here. Therefore, the base angles are congruent. So by angle, side, we have congruent triangles. Therefore, we have corresponding parts congruent. So if this is ABC, I know that triangle AC, let's put an X there, X is congruent to triangle BCX. And by corresponding parts, I know that I know that AX is congruent to BX. So in class today with the ruler, you should have measured the distance from A to X and the distance from B to X, and you would have found that they're the same. So the result is anytime you have a perpendicular from the center of the circle to a chord, it's also the bisector of the chord. The next conjecture says if you have congruent chords in a circle, if you measure them, their distance from the center, distance is always measured at a right angle. Oops. So if you look at this, if I line this straight edge up, that forms right angle with the edge. And if I take this measuring instrument here and see how long this green segment is, it's about 9/10. And if I rotate it, I get just about the exact same measure. So both of these are 9/10. So we know that if you have congruent chords and you want to measure how far they are from the center, that would be at a right angle. Anytime you have your radii perpendicular to your chord, or not your radii, but a segment, the segments are going to be equidistant. From the center. This one says if you have a perpendicular bisector of a chord, so if here's a chord, and we have a perpendicular bisector, of a chord, in order for that to be a perpendicular bisector, we would know that this is equal to this, and this is a right angle. If I want to draw that picture, the only thing that can happen is that that is going to pass through the center of the circle. I don't think that everybody got to that investigation today, but the way that would be done to really show that, other than me just telling you, is to actually take a compass and do the perpendicular bisector, and it should pass through the center of the circle. Of course, with the smart compass, sometimes there's a slight error, but I bet it's going to look pretty close. So let's see what happens here. Now if I take a straight line tool and extend it through the other mark, it just about goes through the center of the circle. So the perpendicular bisector of a chord, if this is a perpendicular bisector, it should pass through the center of the circle. So the big thing today was using these concepts in homework, and I'm going to give you some sample problems here. So, okay, so we're going to apply a few of these conjectures to this set of problems. So it says in exercise 1 through 6, I just picked a few of them. I think I left out one of them. Find each unknown number or right cannot be determined. So on number 1, what you are supposed to notice is that you have a central angle. So a central angle is equal to the measure of its intersected arc. So we know A is 95 degrees. Also, you know B is the supplement, so that's 85 degrees. Since there's an isosceles triangle here, and B is 85 degrees, C has to be congruent to this, so together they have to sum to be 95. So each one's 47.5, because that's 95 divided by 2. So that uses the central angle measure is equal to its intercepted arc. Number 2, when you look at number 2, you have a line through the center of the circle. So that's the last conjecture we just did. Whenever a line goes through the center of the circle and bisects a chord, it has to intersect it at a right angle. So W is 90 degrees. But we don't have enough information to find B. Cannot be determined. Just write that. On number 3, you have a line through the center of the circle that bisects the segment. So we know that this is a right angle. So we have this triangle here. That's an isosceles right triangle. So if you think about that, if this is 90 degrees and these are equal, we must know that this is 45. So Z is 45 degrees. On 4, we have congruent chords. So congruent chords intercept congruent arcs. So if this is 100, W is 100 degrees. We also have an isosceles triangle here. So we know this is 35. 35 plus 35 is 70. So the central angle is 110, which would be equal to Y. So Y is 110 degrees. Then X would have to be the leftover amount. So 100 plus 100 plus 110 is 310. So X is 50 degrees. That uses the congruent chords, cut off congruent arcs. And then this last one, let's see, we have a perpendicular again that passed through the center of the circle. So we know this is a right angle. Therefore, these are bisected. So both of these are 8. We also know that we have congruent triangles here because these are bisected. So by side, zoom in there. We have congruent triangles. So that must mean that this is 50, which is together 50 plus 50 makes 100, and this is 100. So this length X has to be the same as this length here. And so 8 plus 8 is 16, so X equals 16 centimeters. Doesn't look like there's enough information to find Y. So those are just a few sample problems. Let's zoom back out and try applying that to the homework tonight.